accuracy and complexity, right? So here you would just like, you would also need to measure. What do you have to measure here? You have to measure power, which, how do you measure it? Like by voltage and current, and you multiply them together. You also have to keep track of the previous values to see if you have increased the power or if you have reduced the power. So this is somewhere in between. Is it very accurate? Not very accurate, right? But it's a good compromise. You always, like, it doesn't stabilize that much. It doesn't converge to one point. Usually you end up with a region, but it's a good method. So this is just like a introduction to different MPPT algorithms. As I said, there are many more algorithms, and on a basically monthly basis or maybe weekly basis, some researchers comes up with a new paper on MPPT. Okay. One thing I wanted to show you, to give you glimpse of like what are the typical open circuit voltage and maximum power voltages, is, for example, if you have a 12-volt solar cell, or solar array, its open circuit voltage can be 22 volts. So this is open circuit, and its MP, it's gonna be 17 volts. So you remember, like, this ratio between MP and OC is like almost between 70 to 80%. If it's like 20 volt, it can be, for example, 38 volts open circuit, and this can be 30 volts, 24 volts, 44 volts, and 36 volts, right? So just wanted to give you a glimpse of what these values would look like. Now, how do we implement this? That's the main part. So that's actually the part that power electronics comes into our help. So first of all, let me talk about another thing called charge controller. So let's assume that we have a solar panel, right? And we want to supply a load, which is like a house. Okay. So this would generate DC, this would need AC, right? So we saw last time that we need a inverter here, so we can have an AC voltage here. So many times our MPPT algorithm would be implemented in the inverter. Okay, so like this would adjust the voltage here. We also have something called charge controller. So the output here goes to something called charge controller. And from here it goes to our inverter and also goes to our battery storage, right? So let's say that, and this has a certain capacity. Let's say that like we have a very sunny day, so this charge controller would control how much charge goes through how much charge goes through here and how much goes here. So it tries to basically maximize this one first, right, and store energy into our battery. So this is like the battery charger here. And then let's say at night we don't have that much power coming from here, so in that case it would basically get the energy from the battery. So the charge controller is something in control of like how much current goes through the battery or into the inverter, and sometimes these two are merged together. So like the Mppt and charge control are implemented in the same module. Okay, so like if you hear about charge controller, this is basically what it is. Okay, and the charge controller is used like when you want to supply a load using a solar cell. If you want to connect to grid, we don't have that. Okay, but if you have basically something called grid tie inverter, so here this inverter is connected to a house and to our solar panel, so it's isolated. But if you have a solar power plant, means that you want to sell your solar power into the grid, let's say to BC Hydro or to another utility. So in that case, this is called grid tie inverter. So you would have a grid tie inverter. So you have a solar cell, goes to an inverter, and here goes to the grid. Okay, so that's what I wanted to talk about charge controller. Now let's talk about different methods that we can implement this. I'll go through your course notes here as well as some other textbooks. So first of all, let's look at the methods that we can have to control to implement the maximum power point tracking. Okay, I'm going through my notes to find what I wrote for you guys, if I can find it. Okay, so let's go through your course notes here first. So we covered this one, we covered this page, we covered the P&O. This one we'll cover tomorrow. So this is what I was talking about. Okay, so you have a solar panel, you would have a power electronic switch mode power supply that you would control the output voltage of your solar panel using that. It can be a DC-DC converter, it can be buck or boost, and you would have another DC-DC converter in terms of for the sake of charge control, and you supply DC load. As I mentioned, these two can be merged together. Or you would have a grid tie inverter. So this is what I was talking about. So like here you would have your Mppt algorithm, and then you would have an inverter to supply the load. Okay, so this is what I was talking about. This one is in charge of keeping track of the maximum power point, and it can be any